So I will consider something linear in econometrics only if I can see that that is linear in parameters. Otherwise, I will not consider it to be linear. Okay, let's go now to the next topic, which is stochastic specification of population regression function. Now, supposingly, to quote an example, say we have a regression equation. Correspondingly, I have a regression line. This is again the score, and this is maths. This is the income level. Now, for a given income level, different students have different scores. And then I found a mean, and this is the mean. So now, the score of different students would differ from what the mean value I got for that particular income level. That is, there is a difference between actual y that I have got and between the expected value. There is a difference between this expected value and actual yi's. So this difference between y and this expected value is called ui, or the error term. So now what I specified in my first lecture until now, that okay, when I said that you can write y is equal to beta 1 plus beta 2x, and then I said that you have to write e of y given x is equal to beta 1 plus beta 2x. What's the difference between the two? When I say this, when I am talking about this line, when I am talking about this equation, this is actually inclusive of the error term. And when I talk about this equation, this is on the regression line. So this is not inclusive of the error term. So now, because our concept of what an error term is clear, we can write yi is equal to e of y given xi plus ui, which means that the actual yi, the actual whatever y you have, that differs from what the conditional mean is by some error. All the y's rotate around the mean with some error, and there are different errors for different yi's. So there are different ui's, some being positive, some being negative, right? So I can say that ui is equal to yi, actual y, minus this conditional value. And I can also say that now yi is expected value plus the error term. So error is called the stochastic disturbance. Stochastic basically means random. So error is random. It changes. Similarly, because y is connected to the error term, y's are also random, and x is non-stochastic or non-random. So if I have to now interpret this, so supposingly I am given this, and say now I have, this is the mean I know, and this is the score of a particular student for this income level. So how will I interpret it? I'll say that the score of, so this is individual A score, individual A is divided in two parts. One is the mean value and second is the error term. So the total score